Hi, everyone. Today we're going to talk about exponent properties, and we're going to review those ideas. They're going to be super helpful for what we start in chapter 1. I thought, though, because this is a little bit of a shorter section, I wanted to just do a quick review of a difficult problem that you may have encountered in section R.3 on the composition of functions. So let's just do a quick review. You're given two functions, f of x, 4 over x plus 6, and g of x, which is 3 over x, and I'd like you to find each of these compositions here. So if you want, jot the problems down, pause the video, and then come back and see how you're doing. So let me get started. First of all, I'm going to take the g function here and plug it into the f function. So I'm going to take f of the g of x. Now, g of x is 3 over x. So I'm going to be plugging 3 over x into the f function. So it's going to look like this. 4 over, plug in 3 over x in place of the x plus 6. So that would be f of g of x. But we don't leave complex fractions. We want to clean those up. So more of this problem is about cleaning up fractions. So one of the best ways I think to clean up a complex fraction is to multiply the numerator and denominator by the LCD. In this case, the only denominator that we have here is this x on the bottom because the 4 is over 1 and the 6 is over 1. So the LCD would just be x. So if we multiply the numerator and the denominator by x, it will clean up this complex fraction that we have here, and it'll give us a nicer answer. So here's what that would look like. So on the numerator, 4 times x will just be 4x. In the denominator, let's distribute. So we have this x that we're going to multiply by 6, and we're going to do x times 3 over x. So x times 6, that's just going to be 6x. We have a plus sign. Now, when we take x and we multiply by 3 over x, remember this x we're multiplying by is like x over 1. So when we take x over 1 times 3 over x, the x's cross cancel. So they cancel out. And that's the whole reason why I'm multiplying by x. And so you're just left with 3 there. And this would be my answer. Nice and simplified. Can it reduce? No, because there's nothing I could factor out that would cancel. I could factor the denominator if you like. You could take a 3 out of the bottom and, write it this way. But even if you take the 3 out of the bottom, I still don't have a 3 on the top to cancel with. So I could just leave my answer just like this is fine. Okay. It's not wrong to leave it in the factored form. That's okay too. All right, let's try the next one. So on the next one, we're going to take f of x and plug it into g of x. So we're going to be taking g of the f of x. So we're going to take 4 over x plus 6, and we're going to plug that into g, where the x is at. So what we'll have is we'll have a 3 over, and now for x, we plug in 4 over x plus 6. So again, we get this complex fraction, and we don't want to leave it like that. So again, I prefer my method of multiplying by the LCD. So that's what I'm going to do. In this case, we have on the numerator 3 over 1 and the denominator 4 over x plus 6. So the LCD would be x plus 6. So x plus 6 times the top, x plus 6 times the bottom. And so here's what we would get on the numerator. We could distribute, or we could just leave it in a factored form. Let's say we just leave it factored. 3 times x plus 6 over. Now in the denominator, what happens is, this x plus 6 is over 1. We can cross cancel it. That's the whole reason why we're multiplying by x plus 6. And so we're just left with 4. And there's my nice cleaned up version of the answer. And that's how I will want answers, in simplified form, right? Complex fractions are not simplified form. We want to get them down to a nicer fraction. Okay, so that's just a quick review of composition of functions and also of simplifying complex fractions. All right, let's jump into what we're really here for, which is a review of exponent properties. And so in the box here, we've got a nice review quickly that anything to a 0 power, so if you have a 0 exponent, it's always equal to 1. Anytime you have a negative exponent, you can make it into a positive exponent by reciprocating, flipping it over. Fraction exponents can be written as radicals. Okay, and then the general rules about multiplying things with exponents. If you multiply things that have the same base, the exponents add, and if you divide things with the same base, the exponents subtract. And we also do have another product or another rule, shall we say, that might be helpful. You may come across it. If you have something with an exponent raised to another exponent, that particular rule they call the power rule, that is when you would multiply the powers, m times n. Okay, so I'm going to add that rule in there too. Okay, so let's try these out. The main thing we want to make sure you're good at is negative exponents and rational exponents. Those are what give business calc students the most trouble. Okay, so in example 1 here, they're giving us some problems that have radicals in them, and they want us to rewrite them using rational exponents. So let me jot the rule down again. So the rule is, if you have something in the form square root or nth root of a to the m power, you can write that as a to the m over n power. So the n here, that's what we refer to as the index of the radical. So I'll use that term. So the index, if you notice, goes on the bottom of the fraction. Okay, so we have an index there. All right, so let's jump in. So for part A, we have the cube root of x to the 7th power. So writing it as exponents, this would be x to the power of 7 over 3. So notice the index goes on the bottom. Problem B, there is not an index on that one. So what you have to know is that when they don't put an index there, that means it's a square root. So there's really a 2 there. So when we write this, this would be the same as m to the 5 over the index 2, 5 halves power. Okay. And then part C is a little messier. We have a 6 in front of the radical, so let's just leave that 6 where it's at. So we have an index of 5. Now the a on the inside here has an imaginary 1 for an exponent. Let me zoom in here and put a little 1 there. So that's supposed to be a 1. So when we rewrite this, it's going to look like this. So that a to the 1st power, because it has a 5th root, will be a to the 1/5, and the b will be b to the 8/5 power. So because that radical belongs to the a and the b, each of them get that index on the bottom of those fractions. Now the 6 is outside, so you don't do anything with that. It just stays along for the ride. Right, so there it would be. Okay. Now, that's a good review of fraction exponents. Let's look at negative exponents, changing negative exponents to positive exponents. So what if you have 3 to the -2? So remember the rule. Anything with a negative exponent, you can make it positive by reciprocating. Okay. So if you have 3 to the -2, we can make this a positive exponent by making it 1 over 3 to the +2. Well, and since 3 squared is something nice, let's just write it as 1/9. Okay, 1 over 9. Okay, B, we have 5x to the -2 plus 4. So be careful on this. The x has the -2 power, not the 5. So the 5 has to just stay the same. So the 5 stays there. Now that 5 is being multiplied by x to the -2. So it'll be 5 times, let's change x to the -2 to 1 over x squared. Plus 4 just stays here, plus 4, nothing to do with that. And then I can actually multiply 5 times 1 over x squared. Think of 5 as 5 over 1. So when you multiply, this becomes 5 over x squared plus 4. All right, so the 5 stays where it's at, stays on the top, but the x squared flips underneath to make it x to the positive 2. Okay, part C here. We have 1 over 12 x to the negative 4. So we need to clean up this x to the negative 4. So if it's already on the bottom, the way to make it positive would be flip it to the top. So what I'm going to do is take this x to the negative 4 and bring him up here to join the 1. So we have a 1 already on the top. We have a 12 on the bottom. That x to the negative 4, I'm going to reciprocate it. I'm going to flip it up to the top, and it's going to become x to the positive 4. Now, I don't need to keep the 1 there anymore. We can just write it x to the 4th over 12. That would be the better version of problem C. Okay, so notice the 12 stays on the bottom because the negative 4 does not belong to it. It only belongs to the x, unless there's parentheses or something to tell you that it belongs to it, but there's none here. Okay, now here's a 1/2 to the negative 3. Now notice the 1/2 is in parentheses. So that tells you that that entire 1/2 has the negative 3 exponent. So a quick way to do this problem would be, if we want to change a negative 3 to a positive 3, would be to reciprocate it. So change 1/2 to 2 over 1. And then we can change the exponent to positive 3. So you can flip that entire fraction over and change the sign on the exponent. Now 2 over 1 is just 2. So this is 2 to the 3rd, and we might as well just clean that up. 2 to the 3rd, 2 times 2 times 2, that's just 8. So I would say 8 is our best answer here. Okay. All right, so working with negative exponents, muy importante, right? They're going to come up quite a bit, and you want to make sure that you're good at flipping them up and down, changing negatives to positives and positives to negatives also. Okay, let's see. Number 3, simplify each. Okay, so we've got a variety of problems here. So let's just zip through one at a time using our properties of exponents. So problem A, 3x to the 4th times 8x to the 3rd. Okay, 3 times 4, I'll say 3 times 4. 3 times 8 is 24. And then remember the rule that was mentioned, if you're multiplying with the same base, right? So x to the 4th times x to the 3rd. The rule is you keep the same base and you add the exponents. So 3 plus 4 x to the 7th. So 24x to the 7th here. Okay, B, we have this entire thing in parentheses, all of this being raised to the power of 2. So everything in those parentheses gets the squared. So in other words, this squared is going to come into the y term, to the x term, and into the coefficient. So negative 4 will get squared. All right. Now the rule is when we bring the power in, when we take a power to a power, remember that's that last rule I mentioned, you multiply exponents. All right. So we're going to have this negative 4 that is going to become to the 2nd power. We have x squared raised to the 2nd power. So 2 times 2 makes 4. We have y cubed to the 2nd power. So 3 times 2, because we multiply, is 6. Now let's do negative 4 squared. Negative 4 times negative 4, 16. X to the 4th, y to the 6th. There we go. Okay. All right, problem C, we have a division. We have the same base. So the rule for division is you just subtract the exponents. So this would be y to the 24 minus 6. And 24 minus 6, that's going to give us y, what is that, 18 to the 18th power, y to the 18th. So the rule is subtract exponents when you're dividing. Okay, problem D, we have something with a negative exponent. So always with negative exponents, we want to make them into positive exponents. So I'm going to use that rule where I take and do the reciprocal. So this is like 6 over 1. So I'm going to flip it and make it 1 over 6 squared. Now I can make the 2 positive. And then let's do 6 squared and change that to 1 over 6 times 6, 36. 1 over 36. Okay. All right, and last problem E, we have this big term here. Well, one thing we know, you see the Z here, anything to the 0 power is 1, so that's going to just become 1. So Z to the 0 is 1. Let's see, x to the negative 3, we don't want that to be a negative exponent, so we're going to flip that. So let's change x to the negative 3 to 1 over x cubed. Now, if you notice, all these are being multiplied. So that's multiplied by the y to the 4th, which is multiplied by the 1. Now, we can get rid of the 1, right? 1 times anything is just still the same. So let's drop the 1. So 1 over x cubed times y to the 4th. What's that give you? It gives you y to the 4th over x cubed. Right? Because think of y to the 4th as over 1. So you multiply numerators and denominators. All right, so there's problem E. So here we go. So that's a quick review of all the rules of exponents. So you'll get more practice in the homework, but again, focus on negative exponents and fraction exponents, being able to change negatives to positives, positives to negatives, fraction exponents to radicals, radicals to fraction exponents, okay? All right, one last challenging problem here. Simplify this expression. Take a look at that doozy. All right, so we're going to try to simplify this. Now, this is a bunch of algebra. It's going to give you a nice test of your algebra skills. First thing, when you see all these negative exponents, you should think, let's get rid of them. So we have this x to the negative 1, x to the negative 2, and x to the negative 2. All those negative exponents, we are going to flip them. We're going to clean them up. So here's what's going to happen on this. Let's make a big fraction here. All right, we have 1 plus. Now 9x to the negative 1. If you clean that up, if you make that x to the negative 1 positive, that means you flip it to the bottom. So it goes underneath the 9. So this term becomes 9 over x to the positive 1. Okay? So that's what goes here, 9 over x. Plus, now this term with the 20, we have 20x to the negative 2. If we want to make the x to the negative 2 positive, we flip it underneath the 20. Not under the whole fraction, because see, the x to the negative 2 just belongs to the 20. So cleaning this term up would change it to 20 over x to the positive 2. Would look like this. All right, so that's the next term here. So this is going to be 20 over x squared. Okay. And then so on with the denominator. So the denominator, we have 1 minus, and then we have that 16x to the negative 2. So that's going to become 16 over x to the positive 2. Right? So this is the first step. Clean up the negative exponents. Now you have this big complex fraction. And we just reviewed complex fractions a minute ago. We said the best way to clean them up is to multiply by the LCD of this whole thing. So if you look at all the fractions there, what you would have to use as a common denominator, if you were going to say add fractions together, would be x squared. So the LCD here is x squared. And so to clean this up, if you were to multiply everything on the top by x squared and everything on the bottom by x squared. Now this is perfectly legal to do so long as you multiply the top and the bottom. Okay. When you multiply this x squared, it will clear out all these fractions. Okay, it's like magic. So we're going to take this x squared times this term, and over here times this term. And if you need to, think of it as x squared over 1, right? Okay, let's give it a go. So What we should get when we're done distributing the x squared to everybody is a nice fraction with no fractions in it. All right, so first x squared, this guy here, multiplied by 1. X squared times 1 is just 1x squared. Okay, let's do x squared times 9 over x. So maybe over here at the side, let me show you. If you take x squared over 1 and you multiply by 9 over x, what we would do is cancel an x on each of those. And so what you would be left with is 9x. So plus 9x, right? And then 20 over x squared times by x squared, those x squareds just cross cancel. And so you're just left with 20. So look at how the numerator, we've gotten rid of all the fractions there. Okay. Do the same thing on the bottom. Distribute, think of this as x squared over 1 if it helps. Distribute x squared times 1. So this x squared on the bottom times 1 over here. X squared times 1 is just x squared. Minus, when you take x squared and multiply by 16 over x squared, well, those x squareds cancel. And you're just left with 16. So x squared minus 16 is what's on the bottom. Okay, so wow, that looks nice, but hey, there's more we can do. We've simplified in that we got rid of negative exponents. And now we did more simplifying and we got rid of the complex fraction. But now there's more you can do. Hopefully these kind of look familiar here, because what you want to do is you want to factor, because it's possible that we might be able to reduce this fraction. But remember, to reduce fractions, you have to factor. All right, so let's factor. So on the top, let's see, if we factor that, that's a nice trinomial. And everybody's factoring technique is different. I think of, well, what will multiply and make 20, but will add up to 9. And I use a guess and check method. So I know my factors are going to be x and x to make x squared. They're all positive signs, so I know x plus something, x plus something. What multiplies to make 20 that adds up to 9? Well, 5 times 4. So 5 and 4. So there we go. And then, well, how's the denominator factor? Well, that's a binomial on the bottom. And that's what we call a difference of squares. If you notice, we have an x squared here, minus we have a 4 squared here. So a difference of squares factors to x minus 4, x plus 4. And then, well, gosh, look at that. We have a common factor. And we know that if you have a common factor in a fraction, you can cancel it. Cancel, cancel. Finally, I'm to my answer. Answer is x plus 5 divided by x minus 4. Wow. Look at that. That's a lot of algebra stuff to get to that answer. But good practice. Really good practice. Good practice at factoring, simplifying complex numbers, and getting rid of negative exponents, right? Okay, all right, so that was our review of negative exponents, fraction exponents, and just exponent rules in general. Okay, I'll see you in the next video.